Welcome to the lecture of Information System Security. In this lecture, we are going to see about HMAC algorithm. So, what is HMAC algorithm? Hash-based message authentication code. So, it was developed by Meir Bellere, Dan Kennedy, and Hugo Krosigk in 1996. It is specified as Internet Standard RFC 2104. It uses cryptographic hash function in combination with a secret key. Any hash function can be used, like MD5, SHA-1, RIPE-MD160, whirlpool. So HMAC SHA-1 and HMAC MD5 are used within the IPsec and TLS protocols. So there are some design objectives for HMAC. It was set by RFC 2104. So these objectives are to use without modifications available as functions. In particular, to use as functions that perform well in software and for which code is freely and widely available. To allow for easy replaceability of the embedded hash function in case faster or more secure hash functions are found or required. To preserve the original performance of the hash function without incurring a significant degradation. Then to use and handle these in a simple way. Task to have a well understood cryptographic analysis of the strength of the authentication mechanism based on reasonable assumptions about the embedded hash function. So, what is HMAC? HMAC stands for Hash Message Authentication Code. It's a specific technique for calculating a message authentication code involving a combination of cryptographic hash function and a secret key cryptography. So, this is the basic block diagram of HMAC. When the original message is hashed with existing digest algorithms like MD5 or SHA-1, we'll get the message digest. This is encrypted with a key, gives the final output MAC. So the basic HMAC terms, H embedded as function like MD5, SHA-1, type MD160. I is the initial value input to the hash function. M message input to HMAC. Ith block of M, where I ranges from 0 to L minus 1. L is the number of blocks in M. B is the number of bits in a block. N equal to length of hash code produced by embedded hash function. Key equal to secret key. Recommended length is greater than N if key length is greater than B. The key is input to the hash function to produce a n-bit key. So this is the basic HMAC structure and the HMAC implementation. When we see this picture, we can understand that some part of the HMAC is pre-computed and when some part is computed per message. So the secret key with iPad is XORed to get the variable SI, which is given with the hash function with the input value. So it is hashed with the message. Same wise, the secret key with OPAD XOR gives a variable S0, SO, which is hashed with the initial value. The function is hashed to the hash function. So whenever we do HMAC, the XORing of K plus iPad and K plus OPAD is pre-computed. So HMAC algorithm. There are 7 steps in HMAC algorithm. The first step is to append zeros to the left end of K to create a B-bit string K plus. Example, if is a length of 160 bits and B equal to 512, they will be appended with 44 zeros. Then we are going to XOR K plus with iPad to produce the B-bit block SI. After that, we are appending the message with SI. Then we are applying H to the stream generator from the hash, step 3. Then we are XORing K plus with OPAD to produce a B bits of block S naught. Then we are appending the hash result with S naught and we are applying hash again to generate the output, which is HMAC containing a key and message. So we are going to see explanation step by step. The first step is make the length of K plus equal to B. So we need to make the K length correctly. So if the K length is less than B, add 0 bit as required to the left of K. If the K length is equal to B, in this case, we do not to do anything. We can just proceed to step 2. If the length of K is greater than B, we need to trim K. For this, we pass K through the message digest algorithm, selected for this particular instance of HMAC. Step 2 is XORing K plus with iPad to produce SI. So we are going to XOR K plus and iPad to produce a variable called SI. Here iPad is 36 in hexadecimal repeated B by 8 times. This 8 is because of 8 blocks in the message. So the equation is k plus XOR iPad equal to SI. We are getting the SI. Then step 3 is we are going to append the message with SI. So the equation is k plus XOR iPad appended M. So which is the variable SI appended to M. Then step 4, we are going to apply message digest algorithm. In HMAC, we want to apply the message digest algorithm 2 times. So this is the first time in step 4. The selected message digest algorithms like MD5 SHA-1, it is applied to the output of step 3. So the equation is hashing k plus XOR iPad appended M, which is hashing SI appended M. So the input value is like n bits and the hash will give a hash value of SI appended M. Then step 5, we are again going to XOR K with OPAD. So here OPAD is 5C in hexadecimal repeated B by 8 times. The equation is K plus XOR OPAD will give the variable SO. So then the sixth step is to append H to SO. Appending the message digest calculated in step 4 to the end of SO. So the equation is K plus XOR OPAD appended with the hash of SI appended with M. So then the step 7 is going to apply message digest algorithm for the second time. Here we can apply any the algorithms like MD5 or SHA-1, which is applied to the output of 6. Then finally we got the MAC. The equation here is equal to hash of x plus XOR OPAD appended with hash of x plus XOR iPad appended with M. So we get the HMAC with the key and the message. The advantages of HMAC are HMAC is faster to compute and verify digital signatures because they use hash functions rather than public key. HMACs can be used in some cases where the use of public key cryptography is prohibited. HMACs are much smaller than digital signatures, so it takes less time to compute. Whereas the disadvantages are key exchange is a main issue, so can't prevent against replay of message attack, which is man in the middle attack. So HMAC cannot be used if the number of receivers is greater than one. Because if multiple parties share the same symmetric key, how does the receiver know that message was prepared and sent by the sender? So this is all about HMAC. Thank you.